Hello my dear students, this is Akash SD and welcome to the ESD Physics classes. So students, I hope so you all are doing very good and you are preparing very well for your upcoming exams. So students, I hope so now your concepts regarding the ray optics chapter has become very well because I have uploaded so many derivations and so many basics of the ray optics chapter. Even number of questions also I used to upload that you can check in my YouTube channel community tab. Okay, so students, today we are going to learn the prism formula. Okay, in prism formula what we are going to do, in prism formula we are going to find out the refractive index of the material of the prism in terms of the minimum angle of deviation. Now you will may think how the prism will look like. So in prism, actually the prism is the three-dimensional body. Okay, in a prism what will happen, there will be the two reflecting surfaces and one base will be there. Okay, that will appear on your screen also. That shape of the prism you can see there. Okay, so students, what we are going to do, we have just taken here one prism. What I told, prism is the three-dimensional, but here I have taken the two-dimensional shape. Okay, so now what I am going to do, I am going to draw the diagram. You just track it very well how we will draw the diagram. Okay, so what we'll tell here, students, here the prism is there. No, so here first let me give the name here. This is the A, no, this is the B, and this is the C. Okay, and here one angle will be there. This angle is called the refracting angle of prism or the prism angle also. I will use here the A term only for the prism angle. After that, this is the first reflecting surface AB, and AC is the second reflecting surface, and this BC is the base of the prism. Okay, so what will happen that here one incident ray will go and strike the reflecting surface AB, but when I will draw the reflecting ray, then what I need the normal. Okay, so what I am going to do, first I am going to draw the normal here. Okay, so just let me draw the normal here, students. Here I have taken this normal. See this is a normal here. No? This is a normal. No? Now this normal I have taken N1. Okay, so now what I will do here, I have just taken one ray is there. Okay, just let me choose it, please. See, this is the, now this is the ray is there. Which ray is there? This is the incident ray is there. Now let me name it. This is the P, and let me just write here, this is the Q. Okay, and this ray is making some angle from the normal. This angle I will tell here I. Now what will happen that here the ray will travel from one medium to another medium here. Now let's take for example, here air is there, so I have taken mu r. Okay, here this prism is there made up of glass and all, so I have taken mu d, and again this side I have taken again mu r. Okay, so what I am telling, when the ray will go and strike the first reflecting surface, then what is happening, the ray is going from the rarer to which medium, denser medium here. Okay, so what will happen that here, it will bend towards the normal and it will go like this here. Okay, and let's take, students, this angle is I have taken R1. Now what will happen that here, just see here, when the ray will reach at the second reflecting surface, here what will happen, it will go from which medium to which medium, denser to rarer medium. That means it will go away from the normal. So for that what I will do here, I will just draw here the again. Now let me draw here the again this normal here. Now this normal, this is a normal, I will just take the name here N2. This is the N2. Now again the ray will go away from the normal like this here, and this angle I have taken I2. So students, this is P, Q, this is R, and this is S. So what I am telling here, this PQ is the incident ray, QR is the refracting ray, and RS is the emergent ray. Okay, now what I will do here, I am going to find out the angle of deviation. Okay, so just let me draw here. Just let me draw here, please. This one here. Now, so see it, please. Actually, what is happening? The ray should go straight like this. The ray should go straight. But what is happening that here? The ray has bended. The ray has bended. So here, what will happen that here this angle is called. I will just change the color here. No, see, this angle is called the angle of deviation. At which surface? Angle of deviation at the first surface. Okay. Now after that, if I want to find out angle of deviation at the second surface, then what I have to do, again I have to draw the ray here. Now just let me draw here the ray, please. Now see this one, this I will take it. This one, let me take it here, back side here. Okay, so what will happen that, dear students, just see here, please here. Now this one here, this is the angle of deviation at the second surface, delta 2, and you can see very well, this is the incident ray. and this is which ray? Emergent ray. So this angle will be the angle of deviation, total angle of deviation. Okay, and just let me write the names here. Okay, so this is PQRS. This I am telling here T. Now this name I have taken here T. So now I hope so, students, this diagram is very clear to you. Again I am telling you, I1 is the angle of incidence. This I2 is the angle of emergence. Delta 1 is the angle of deviation produced at surface AB. Delta 2 is the angle of deviation produced at surface AC, and this delta is the total angle of deviation produced by the prism. Okay, and the prism is having some material, its refractive index is mu d, refractive index of this surrounding mu r, and that surrounding is also how much here? That surrounding is also mu r. Okay, now students, when we will do the derivation, some introduction we have to write that will appear on your screen. Here what we will do, we will just do the mathematical part. Okay, so students, just start here. No, just we are going to start. So students, just let me write please. No, let me take here the which color, and we'll take the white color here. So students, if I talk about here angle of deviation at first surface here. So see here, let me write here. I'm writing here angle of deviation. Angle of deviation at reflecting surface AB. Now, at which surface? At reflecting surface AB. So I will write here angle of deviation at AB. So you can see here by the geometry also what will delta 1? I can write here this delta 1 is a I1 minus R1. Correct? This delta 1 is what? I1 minus R1. Now let me write in a box please. Now, and this is equation 1. After that, what I am going to do? This angle of deviation at reflecting surface AC. Again, let me change the color here, please. See now again. Now, angle of deviation. Now, angle of deviation at which surface? At this one. At surface AC. Reflecting surface AC here. So again, if we do here, what will be the delta 2? Delta 2 is given by I2 minus this angle. This angle is the R2. So I can write here. This delta 2 is equal to I2 minus R2. Okay, this is also we have got one equation. Let me write here the equation 2. Now the total deviation, the total angle of deviation, how to write here? Students, the total angle of deviation here, just let me write here. See the total angle of deviation, total angle of deviation. Just guess please, the total angle of deviation is given by which term? This delta. So this total angle of deviation is given by here delta equal to delta 1 plus delta 2. Even this thing you can check in the triangle TQR also. The sum of the two interior angles delta 1 plus delta 2 is equal to the exterior angle, and that is the total deviation also. What we have written? Delta equal to delta 1 plus delta 2. Now what we'll do? This delta 1 and delta 2 value we will put from equation 1 and 2. Okay, so just let me write here. What will happen that here? Delta 1 is given by this one, I1 minus R1. Delta 2 is given by I2 minus R2. So hence this total angle of deviation is given by I1 plus I2 minus R1 plus R2. Okay, this is a very standard equation is there. Now let me write here. And this one I have taken equation 3. Okay, so I hope so. Up to this is very clear to you. Now what we are going to do? We are going to find out this R1 plus R2. Okay, so students, just let me write here. No? Or I will go to the, actually I need this diagram here. No? So I will write here still. Now I will just change the color and just I will just write here. Okay, just let me change the color. Yellow color I will use here, and I will just write here. This side I will write here. Okay, so students, just kindly see here. In triangle, this triangle I am using. AQR, in triangle AQR, in triangle AQR. So what is happening, students, here please here? This one here, this is the angle A plus. Can you guess the triangle, this one? This actually angle AQR. Now what I am using is here, this AQR plus angle, one more angle I will use here, ARQ. ARQ. This total angle will be how much here? This total angle will be 180 degree here. Now the reflecting angle A plus. Just guess please, what is the AQR? This AQR. You think this here. This is the R1. If this is the R1 means this angle how much here? This angle, this angle. No, what I'm telling, this angle, this angle. So this angle will be how much here? 90 minus R1. What I'm telling? 90 minus R1. Similarly, guess please, this angle ARQ. So this is R2. This is a 90 degree. So this angle how much here? 90 minus R2. 90 minus R2 is equal to 180 degree. Hence, what we can get here? If you will simplify both the sides, it will come here. R1 plus R2 is equal to A. Now, and what is there? This one I have made it equation 4. Now, so students, we have written all these equations. Now, what I will do here? This R1 plus R2 I will put in this equation. Which equation? In equation 3rd. Okay. So just let me write here, please. Here, students, as we know that from 3 and 4. What I am writing? From equation 3 and 4. So just let me write here. Equation 3 was what? Delta equal to I1 plus I2 minus R1 plus R2. And from equation 4, what was the value of R1 plus R2? A. So we can write here this what we can tell, see, delta equal to I1 plus I2 minus A. And this equation is very, very important equation. This is equation number I have taken 5. Okay. And after that, dear students, we have to remember one more thing also. This graph here. This graph is there. This here. This also they used to come in exam. This is delta. This is I. And what will happen that here? The graph we used to come like this here. Okay. So what will happen that students here? Just let me write here. What will happen that if I draw here one line here? Just let me draw here one line, please. Like this here. See. So if I draw one line like this. So students, you can see here how many possible angles are there. For one angle of deviation, we have the 2 possible angles. What is this? 2 possible angles. Remember that here. If this angle is I1, this angle will be I2. Remember that this very well. If angle of incidence is I1, then angle of emergence how much? I2. From the reversibility of light also. What is happening that here? See here, please here. Again I will draw here that triangle here. See here, please here. See here triangle here, please. Now this is a normal. This is a normal here. See here, please here. This ray is going. This ray is going and this ray is going. So what I am telling is that here? I am telling that here this angle I1 and this angle I2. So what is happening? If angle of incidence is I1, then angle of emergence how much? I2. Similarly, even we can change also. We can change also. See, if the light is going in this direction, then it will come like this here. Okay, this is called the reversibility of light. Here what is happening? Angle of incidence is I2 and angle of emergence is I1. That means what will happen? For the 2 same kind of angles I1 and I2, we will get the same angle of deviation. And here what will happen that students, at this point what will happen that here this angle of deviation will be how much? Minimum. And at this point what will happen that students, just let me write here. At this point only this I1 will be equal to I2. When I1 equal to I2, that time only what is there? The minimum angle of deviation will be there. Okay? Yes. So now students, I am just going to write the minimum angle of deviation condition here. Now, so let me write here. What is the condition? Condition for minimum angle of deviation. Okay, what is this? The condition for minimum angle of deviation here. Okay, write the conditions please here. Here the first condition I am going to write here. One thing, I1 equal to I2 equal to I. First condition, I1 equal to I2 equal to I. And what I have taught you, see here please, as what equation we know? We know the equation as delta equal to I1 plus I2 minus A. This is a general equation. Applicable in all the kinds of situation. But when I will write I1 equal to I2 equal to Y, then this is applicable only in a which situation? Minimum angle of deviation. So what we can write here? Just let me write here. When this delta will become delta minimum, here we will write here I plus I minus A. Okay. So what will happen here? Here we can write here this delta minimum is given by 2I minus A. Okay. Or hence we can write I equal to A plus delta minimum by 2. And students, this condition is applicable only in a minimum angle of deviation condition. This is applicable all the times, but this is applicable only in a minimum angle of deviation condition. Okay. After that, one more thing here. Just let me write here. This second equation we know that. See, second condition actually. So what is the second condition? For the minimum angle of deviation, what will happen? This R1 is equal to R2 is equal to R. Is it? And you remember we have seen this equation here. What was the equation? R1 plus R2 equal to A. Okay. So this equation we are going to use in a second condition of the minimum angle of deviation. And this is the equation number 4 here. So what will happen that here? See here please again students. See from equation 4 what is there as R1 plus R2 is equal to A. Then right here please R plus R is equal to A. Hence R how much? R how much? R is given by A by 2. Again this condition is only applicable in a minimum angle of deviation condition here. Okay. So this is equation 5. Just let me make it here. This is equation 6 and this is equation 7. Okay. So these many equations we have made it. Now we are completely ready to find out the refractive index of the material of the prism. Okay. So students, what I am going to do now here? I am going to use the Snell's law here at point Q. What I am going to do? I am going to use the Snell's law at point Q here. Okay students. So just let me just rough this actually. This I'm just going to rough this. I will just take somewhat bigger one. No, this one here, and here I'm going to use it. Okay, because students now here we have the what to tell, the diagram is there, so here we can do it very well. No, so just you think please what is the angle of deviation condition we have seen now, and after that the Snell's law. Okay students, so Snell's law, do you remember what was the Snell's law students? Just tell me this here. Snell's law, according to Snell's law, mu into sin theta will be constant. Okay, so just let me write here Snell's law. Snell's law at point where? At point Q. So students, just let me write here. Here what is there? Mu r, angle I1. So what we can write here? Mu r into sin I1 is equal to, at this side what is there? Mu d into sin R1. What is there? Mu d into sin R1. Now students, if you will simplify this here, what this will come here? Mu d by mu r is equal to sin I1 by sin R1. This one we have got it. Correct? Now, if we use for the minimum angle of deviation, what I am telling? For minimum angle of deviation. For minimum angle of deviation. So what will happen, students? Please here. See here. I will write here. Mu denser with respect to rarer. Okay, is given by, what is this? This will be sin I, and what is this? Sin R. Now just let me write here. After that, what I have taught you, just to go next one here. What I have taught you for the minimum angle of deviation, I was how much? A plus delta minimum by 2, and R was how much? A by 2. These values of I and R we will put in our previous equation here. Okay, so just let me write here. Then what will happen that here? We can write here, hence mu denser with respect to rarer is given by here. This here, this here. I will just change the color somewhat here. Now this I am going to use here. Here, this here. This will become here sin A plus delta minimum by 2, and here what is this? Sin A by 2. And what is this? Students, this is the Prism formula. What is this formula? This is the Prism formula here. Whenever we are solving the numerical, for numerical we can just write sin I by sin R. We can calculate the required values. But when we are doing a derivation, we will reach up to this. But remember that here, this is the, what to tell, this is the exact formula you can use for any angle. But sometimes what happens that if in the prism, they are giving the angles are very small, then what will do here please? No, what will do here please? Let me go ahead with the next one here. No, next one here. So see here please, here students, what is there here? See, see here please. For prism angle, for prism angle A less than 10 degree, less than 10 degree. So here what will happen that when the prism angle is less than 10 degree, here we have to use the approximation of the technometry. That time what we know? We know that, students, we know that this sin theta will be approximately equal to theta. Okay, and students, as we have proved the prism formula, so what is the prism formula here? Just let me write here please. See, I will write here as what we know, we have seen mu dr. I will just write mu. Mu means denser with respect to rarer. Okay, so what will happen? This mu is what we have proved here, sin A plus delta minimum by 2, and here what is this? the sine A by 2. And what I have taught you, when the angle is very, very small, then sine theta will become theta. That means, students, what we can write here? We can write here, see please, here we can write mu equal to, this sine theta will become theta. That means, just let me change the color here, please. Now, see this one here, please. So what we can write is here, please, A plus delta minimum by 2, and here A by 2. Okay, sine theta has become theta. Then what will happen? That here 2 and 2 will cancel. So it will become here A plus delta minimum by A. And when we will simplify this, students, so what will come? This delta minimum will come mu minus 1 into A. Okay, mu minus 1 into A. And let me put into the bracket. Okay, so students, here we have learned the very basic of the Prism formula. So please remember that one thing. Again, I am telling you very clearly, please. Just let me go to the back here, please. As I have told you the formula, delta equal to I1 plus I2 minus A, and R1 plus R2 equal to A. These two formula is applicable in any kind of situation. After that, what I have told you, minimum angle of deviation condition. And there, how many conditions we have got? The two conditions. First one, I equal to this one, A plus delta minimum by 2, and R equal to A by 2. And one more thing, for the minimum angle of deviation, the third condition will be this ray QR will be parallel to the base BC. So these three conditions we will only use in a minimum angle of deviation condition. Okay, and the second last thing is that this formula you can use for any kind of prism angle. Even the equilateral prism is there, angle of refraction will be the reflecting angle of the prism will be 60 degrees. So there also you can use this formula here. But if in case in the question they told the angle of prism or refracting angle of the prism, that is the less than 10 degrees, then what I have taught you, students, here please, what I have taught you, I have taught you this. Okay, so please be very careful. When the angle is very small, then only you will use this formula. Otherwise you will use the sine formula that I have done here, this formula here. Okay, so I hope so, students. Now this derivation is very clear to you. Just study it very well, because this is regularly coming in a board exam. Okay, students, so if you have understood this class very well, just like this video and subscribe to my channel. Okay, and keep preparing. Okay, God bless you. Thank you so much.